Okay, in this video, we'll discuss about the law of moment. Okay, that is normally called as Varignon's principle. So in the previous video, the moment related to moment, I explained what you mean by the moment here. It is nothing but the product of the force and its perpendicular distance, where about which point you want to find out the perpendicular distance. That is one definition. Also, one more definition is that is the moment is nothing but the moment of a force about any point is nothing but the 2 times the area joining whatever the force, the baseline of the force into where the point is there. If you want to join, make a triangle, 2 times triangle, that is nothing but the moment of a force about that point here. There are 2 formulas are there you can use here. Okay, now what is the law of moment here? Okay, that is normally called Varignon's principle. First we'll see the statement here. It states that if the number of coplanar forces acting simultaneously at a point, there are so many number of forces acting at a point, that is number of coplanar forces acting simultaneously at a point, be represented in magnitude and directions. They have some certain magnitudes and direction. The algebraic sum of moments of, that is summation of, that is algebraic sum of moments of these forces. It means about any point. If you want to find out, suppose if you want to find out the moment about this point, just make the first moment of this force, just calculate moment of this force, calculate moment of this force, calculate moment of this force, then make it sum. That is algebraic summation of, that is moment of these forces about any point, that is this point, about any point is equal to that is the moment of the resultant, whatever you are finding, the moment of resultant about the same point, It means if you consider this point, first make it the moments of all these forces and add this one. That is nothing but whatever the moment of the resultant about that point here. That is the definition of the Varignon's principle. Once again I'll read. It states that if number of coplanar means in the same plane, coplanar forces acting simultaneously at a point be represented in magnitude and directions, then the algebraic sum of moments of these forces, algebraic sum of moments of these forces about any point is equal to the moment of resultant force. This is the moment of resultant force about the same point, This is how the definition of the Varignon's principle and law of the force here. Okay, now we'll prove how we can get the total algebraic sum of moments of the n number of forces is equal to the moment of the resultant force, here. Okay, that is proof. Now we'll start with the proof here. For simplicity, we'll consider 2 forces. Okay, consider 2 forces P and Q. Represented in magnitude and direction, by AB and AC, by the line AB and AC, by the lines AB and AC. Okay, by the lines AB and AC. Just I'll consider 2 forces, that is, this is the first force P, this is AB, AB, and second force is AC. This is Q force. Okay. Consider two forces P and Q represented in magnitude and directions. You have certain magnitude and directions by the lines AB and AC. The second point is, let O be the point. About which moment of P and Q is required. Moment of force P and Q required. Q is required. It means there are two forces are there. Here somewhere, let O be the point. This is the O point. Let O be the point about which the moment is required related to P and Q here. Okay. Now through O, through this point, draw OD parallel to AB here. That is force P. Draw through O, draw OD parallel to AB, the force P, that is AB, force P. Just I am drawing here, just P. You just draw the OD, where somewhere D is there. Just I'll explain later here. OD parallel to AB. OD parallel to AB here. This means, that is, on OD, just this is OD parallel to, that is OD. This is OD, just somewhere D is there. OD parallel to AB here. Next, on OD, the force Q meets the force Q meets at C. It means just extend your force Q, that is here, it meets at C. Here. Okay. Now with AB and AC, these are two, just consider these two are the adjacent sides of a parallelogram. Now complete the parallelogram. By considering, that is, by considering AB, AC and AB are two adjacent sides of a parallelogram. Complete other two sides. Complete the parallelogram. By joining other two sides. It means you need to join other two sides. That is where the same, this is the D point here. Okay, you are joining other two sides of a parallelogram. Now join DA. That is, you want to join, because join AD, this point. The next point is join AD. Why I am joining here? Because in the previous video you saw that law of parallelogram. If two sides of the forces are represented by the two sides of a parallelogram, then the diagonal represents the resultant of these two forces here. It means I can write AD as the resultant here. AD as the resultant. Okay. Now the next point is by the parallelogram law of forces, the resultant of forces P and Q. P and Q is what? The resultant of forces P and Q is Q are nothing but R. It is diagonal. That is diagonal, right? Diagonal. That is diagonal here. Now the next point is we know that now join before this one here, join AO and OB. Join, the next point is join AO and OB. Okay, join AO and OB. AO and OB. Now by considering this diagram, you need to prove that the summation of or algebraic sum of the moments of P and Q about O is equal to the moment of this R about O. This is the law of the moment here. That is Varignon's principle states. Now we'll prove the same here. Okay. As we know that moment of Q, moment of P about O is what? Moment of force P about O is what? You know that already. You have ABO is a triangle. You have P is here force. So the moment of this force P about O is 2 times the area of triangle ABO, right? 2 times the area of triangle ABO. That is the 2 times area of triangle AOB, right? Did you agree? Okay. Now this is force P. Now come to the same force Q, the same moment of force Q. What is the moment of force Q about O? It is nothing but the 2 times area of triangle ACO, right? 2 times the area of triangle ACO. The moment of force Q about O equal to 2 times area of which triangle? Area of triangle ACO, right? That is ACO. Did you get the point? Now come to the resultant force. If you want to find out the resultant of this resultant about O, what is that? That is the moment of this resultant about O is equal to 2 times area of ADO. I'll write the same. The moment of the resultant. R about O equal to 2 times area of triangle ADO, right? Did you agree? That is triangle ADO here. Okay, now just I'll go here one by one, just concentrate here. Now the area of, that is the resultant is the moment is the 2 times the area of ADO. How will represent area of ADO here? That is the area of ADO is nothing but the area of OAC, the area of OAC plus the area of CAD, right? Will you agree? Once again I'll explain. The area of ADO equal to the area of OAC plus the area of CAD. Can I write that one? But area of triangle ADO equal to area of triangle OAC plus the area of triangle CAD, right? Area of triangle CAD. Now, how will write the area of triangle CAD? CAD, is it same as that of the angle, the area of DAB? Because it is a parallelogram. The diagonal is exactly dividing the area. So, can I write the area of CAD is nothing but the area of is equal to the area of DAB. This is nothing but, this I can write it as the area of triangle CAD is nothing but the area of DAB, that is area of triangle DAB. Will you agree? Okay, now because I will write here, because the triangle area of triangle CAD equal to the area of triangle DAB, because it is a parallelogram. The diagonal is divided into two areas into two halves. Now again same, that is, can I write this area of triangle DAB is nothing but the area of triangle OBA. Why? Because the baseline is same. So whatever the area is there, DAB is equal to the area of triangle ABO. That is, this I can write it as area of triangle DAB is nothing but area of triangle OBA. That is OBA. Can I write this one? Because both triangles OBA and DAB are on same baseline AB. Okay, same baseline OB here. So now finally I'll just write the same in the left side here, that is area of triangle ADO, that is resultant. ADO is equal to, first I'll write same area of triangle AOC, that is area of triangle AOC plus what I can write next, area of triangle OBA, area of triangle OBA, right? Okay, now area of triangle, just multiply both sides by 2. Now multiply both sides by 2, by factor 2. What you will get here? That is, the left side is 2 times area of triangle ADO equal to 2 times the area of triangle AOC plus 2 times the area of triangle OBA, that is OBA. Okay, now the 2 times the area of triangle ADO, what is that? It is the resultant, because the resultant is AD, you want about O, you want the moment about O, you made a triangle. So 2 times the area of this ADO is nothing but the moment of resultant about O. Can I write? The moment of this resultant about O is nothing but 2 times the area of triangle ADO. Okay, that is, this I can write it as the moment of resultant R about where? About O equal to, what is the 2 times area of AOC? Where is AOC? A, O and C. AOC, related to AOC, which force is there? That is Q. Can I write the moment of Q about O? Because this is a triangle. That is the moment of Q about O. Is it right? Plus, how should I write next one? Plus moment of next one is OBA. Where is OBA? This is O, B and A. This is the triangle. To this triangle, which force is there? This is P. It means, can I write the moment of force P about O? That is the moment of force P about O. Okay, this is how the total resultant here we need to prove. That is, moment of resultant about R about any point is equal to the summation of the moments of the forces about the same point. That is, this is one of the derivation. I can write this one also. That is the moment of resultant about any point about the same point is equal to summation of, that is algebraic sum of moment of forces about any point. Will you agree this one? About any point means these all forces about O is the same as that of the moment of the resultant. Moment of the resultant about the same point. This is how the Varignon's principle, it will be explained here. Okay. So this is the derivation and law of moment. Okay. So finally, if n number of forces acting at any point, if you want to find out the resultant moment, you need to apply the law of moment. What it will tells? The summation of, that is algebraic sum of n number of moment of the forces about any point is equal to the moment of the resultant about the same point. This is how you need to apply here. This is only for 2 forces, but you can apply the same law for the n number of forces here. Okay.